Hey, Math 30-2, today we're going to look at multiplication of rational expressions. So a quick review of multiplying rational numbers or fractions. Recall these steps for multiplying fractions. Consider the factors of the numerators and of the denominator. Alright, so always looking at factors. If there are factors common to the numerator and the denominator, reduce these by dividing out those common factors. Alright, so I always want to reduce by dividing out. Once we've reduced, let's go ahead and multiply the numerators together and then multiply the denominators together. Note that steps 2 and 3 may be interchanged depending on what's easiest. So example 1, multiply 7/10 by 1/5. Well, there are no common factors in the numerator and the denominator, so we simply multiply the numerators, 7 times 1 over the denominators, 10 times 5. Always check and see if you can reduce. Well, we can't reduce 7 over 50, so that's lowest terms. Part B, look for common factors in my numerator and denominator. Simplify. I suggest we do that first. So both the 10 and 20 can be divided by 10. That leaves 1 and 2. The 9 and 21 are both divisible by 3. So that leaves 3 and 7. So if you reduce first, then you go ahead and multiply. 3 times 2 is 6. Over 1 times 7 is 7. If you've done that properly, your final answer should be in lowest terms. All right. Multiplication of a single variable rational expression. So now we're going to talk about fractions with variables in them, or we call those rational expressions. The method for multiplication of rational expressions is similar to the method of multiplication for rational numbers. One of the steps not stated, though, is to factor our numerators and denominators before we start multiplying. All right. So let's consider the multiplication of x plus 1 over x plus 3 by 2x plus 6 over x squared plus x. Step 1 should be to factor anything we can. So x plus 1, x plus 3, they're already factored, but 2x plus 6 has a common factor of 2, and that leaves us with x plus 3, and x squared plus x has a common factor of x, and that leaves us with x plus 1. So because I'm multiplying, I can write this all as a single multiplication statement for my numerator and my denominator. And once I've got everything factored, I can now reduce any numerator with any denominator. So x plus 3 divided by x plus 3 leaves 1. X plus 1 divided by x plus 1 leaves 1. And 2 over x can't be reduced. So in simplest form, I've got 1 times 2 times 1, or 2 in my numerator, 1 times x times 1, or x in my denominator. Now, very important to notice, I've simplified, and if I were to state non-permissive values right now, I've only got one variable term. That variable term is x. So it would be correct to say that x can equal 0. Now, if you look up in the top of the question, it tells us that x can equal -3, -1, or 0. And that is correct. We've made a mistake here. Our mistake was we simplified this statement before we stated our non-permissible values. So before you start dividing out any common factors, we should state our non-permissible values. So x can equal 0. That's correct. But x also can't equal -3, so we should also have that. And x also can't equal -1, so we should have that. So we should state our non-permissible values before we start reducing any like terms in our numerator and denominator. Now I can get rid of my x plus 3s, they reduce to 1. Now I can get rid of my x plus 1s, they reduce to 1. So before I reduce any denominators that have variables, I should state my non-permissible values. All right, so this is our correct answer. Those are the correct non-permissible values. Okay, let's try another example. Example 2, simplify the following, stating the non-permissible values as restrictions. All right, part A. Step 1 is always to factor. Holy smokes. Step 1 is always to factor. What happened? There we go. So simplify the following. Let's factor any numerators and denominators that we can. And because it's multiplication, I can write these as one big multiplication statement in my numerator. So the common factor of 4x minus 16 is 4. Divide 4x by 4, I get x. Divide negative 16 by 4, I get minus 4. To that, I'm multiplying the other numerator of 2x minus 1. That is all over. In my denominator, 14x minus 7, well, that's got a common factor of 7. Divide 14x by 7, I get 2x. Divide negative 7 by 7, I get minus 1. That's multiplied by x minus 4 all squared, which is like saying x minus 4 times x minus 4. All right, so that's great. I've now written this statement in complete factored form. I can now reduce any numerator with any denominator, but from what we saw last example, I want to make sure I state my non-permissible values before I do any reducing and lose any of my variable factors in my denominator. So 2x minus 1 as a non-permissible value, x can't equal add 1 and divide by 2, which is a half. Here, x minus 4, they're the same, so x also cannot equal positive 4. All right, so those are our non-permissible values. Now I want to go ahead and reduce any numerator with any denominator. So x minus 4 and either one of these, not both of them, but one of them can be reduced. So they reduce down to 1. 2x minus 1 divided by 2x minus 1 is also 1. So I am completely finished reducing common factors in my numerator and denominator. So let's simplify. 4 times 1 times 1 in my numerator over 7 times 1 times 1 times x minus 4 is 7 times x minus 4. So there is our simplified rational expression. These are our restrictions. So make sure we find our restrictions before we reduce any common factors in my numerator and denominator. So step 1 will always be to factor. In my numerator, first numerator, 2x cubed minus 4x squared, that's got a common factor of 2x squared. So 2x cubed divided by 2x squared is x. Negative 4x squared divided by 2x squared is a minus 2. And I'm multiplying, so I can multiply that by x squared. And my denominator, 3x squared minus 9x, that's got a common factor of 3x, and that leaves 3x squared divided by 3x is x. Negative 9x divided by 3x is a minus 3 times x squared minus 4. Well, that's a difference of squares. That factors as x plus 2 times x minus 2. All right. So if I want to maybe just go one more step, I can simplify my numerator, 2x squared and x squared. Because those are both monomials, I could multiply those together and write this as 2x to the 4th times x minus 2 in my numerator. My denominator would stay the same as 3x times x minus 3 times x plus 2 times x minus 2. All right. So right now I have factored both numerators and denominators. Before I start reducing any like terms, I should state my restrictions. So restriction of 3x, we know that x in that case can equal 0. X minus 3, so x can't equal positive 3. X plus 2, so x can't equal negative 2. And x can't equal positive 2. So x can't equal plus or minus 2. So there are restrictions. Now I go ahead and reduce any numerator with any denominator. Well, x and x to the 4th can be reduced. X to the 4th divided by x is x cubed. And x minus 2 divided by an x minus 2, they both reduce down to 1. So I'm done reducing any numerator with any denominator that's a common factor. Now let's simplify this. 2 times x cubed in my numerator times 1 over 3 times x minus 3 times x plus 2 times 1. So that is our simplest form of this rational expression after I multiply. There are our non-permissible values. We found those before we divided out any common factors. All right, so pretty straightforward, very similar to when we were doing simplifying rational expressions. Away you go. Try the questions from 1 to 7.